Okay, so let's talk about complex zeros, because I'm sure you wanted to know more about them. One bit of fascinating piece of information is that complex zeros always occur in pairs. Excuse me. So what this means is if the complex number a plus bi is a zero of a function, then so is a minus bi. Okay, those are called conjugates, if you remember from earlier this year, which is actually really, really helpful. So what we want to do in this next problem is find a fourth degree polynomial functions with real coefficients that has these zeros. Okay, so we have zeros of 2, -2, and -7i. Well, we know that complex zeros occur in pairs. So if -7i is a zero, so is +7i. So now, it was a fourth degree, where they were already told that, and we have all four of the zeros. So now we can write all four of the factors. If a 0 is 2, that factor is x minus 2. If a 0 is -2, that's x plus 2. If a 0 is -7i, that's x plus 7i. And if a 0 is 7i, that's x minus 7i. Okay, so from our zeros, we get our factors. So now all we have to do is remember they wanted real coefficients, so we need to FOIL this all out and make it look pretty. So let's start here. X times x is x squared. X times 2, x times 2 is 2x, and -2 times x is -2x. Those are going to cancel, so we don't have to worry about those. And then we get -4. Okay, let's come over to this one. X times x is x squared. Then we have x times -7i and x times +7i. Those are going to cancel, so we don't have to worry about them. So we just get -49i squared. Now, before we go any further, just rewrite this. Remember, I squared is the same thing as -1. So this is -49 times -1, which is +49. So that's good news. That makes that thing a lot easier, as we've gotten rid of all of our i's, and all we have to do left to do is to FOIL this out. So we get x to the 4th plus 49 x squared minus 4x squared minus, I don't know, 196. And combine our like terms. I'm going to put my answer up here because I'm running out of space. X to the 4th plus 45x squared minus 196. So this is the polynomial that has zeros 2, -2, and -7i and +7i. Okay, let's do the next one. Also, if you're planning ahead, we are not going to do part C, so feel free to use all the space up. Oop, I don't know what happened there. Okay, so we know that this has zeros 1, 3, and 4 minus I, which means that 4 plus I is also a 0. So let's write the factors that go with that. This one's going to be x minus 1. This is going to be x minus 3. This is going to be x minus 4 minus I. And this one's going to be x minus 4 plus I. Okay. I don't know, what do you want to do first? Easy or hard part? You want to do the easy part first, I know. Okay, fine, we'll do the easy part first. We need to FOIL out, we're going to FOIL out the first two things. So we'll be fine, we can handle this. We get x squared minus 3x minus 1x, so minus 4x plus 3. Okay, next one. I'm going to rearrange the parentheses, and there's a method to my madness, even though you don't believe me. I'm going to write it as x minus 4, if I did like distribute that negative through, this is x minus 4 plus I. And I'm going to distribute that negative through. So this is x minus 4 minus I. Now, I could do one big massive like FOIL problem with those two, but here's what I'm going to do instead. I'm going to treat this like a single unit. The reason I did that is because I have x minus 4 plus I and x minus 4 minus I. I'm going to get some middle terms that cancel. Okay, let's hopefully we can figure this out. That green thing over there, leave it alone. We'll be back to that. So we have x minus 4 times x minus 4. I'm just going to write that as x minus 4 squared. I will deal with that in a minute. Then x minus 4 times negative I and x minus 4 times positive I, those are going to cancel. That's why I rearranged the parentheses, because I knew I could get it to be opposites and cancel. So I don't even need to write those down. And then I have I times negative I, so minus I squared. See how easy that was? Well, not easy, but less hard than you thought. All right, this is a FOIL problem, x minus 4 times x minus 4. So we actually have to do that, x minus 4 times x minus 4. Wow, that did not come through very well. Minus I squared. Remember, I squared, that's just negative 1. We'll be back to that. So we're going to FOIL this out. We get x squared minus 4x is minus 8x. Negative 4 times negative 4 is plus 16, plus another one is 17. Okay, so that was all the second half. Remember that green thing I said we'd come back to? Here it is. Okay. So now we need to do like one big massive FOIL on these two things. We can do that. We've made it this far. All right, x to the 4th minus 8x cubed. Is that a 17? Plus 17x squared. Something that I like to do once I get to this point is I like to start lining up my common terms, my like terms. I'll show you what I mean. So next I'm taking negative 4x times x squared, and that's going to be x cubed. So I like to write it underneath my x cubes. Rather than writing it all out in one big long line, then I lose track of where all my like terms are. All right, negative 4x times negative 8x is going to be positive 32x squared. And negative 4 times 17, I don't know, I'm going to use my calculator. 17 times 4, 68. Negative 68x. Now, I still have one more FOIL to do. It's this 3. So I get 3x squared. I'm going to write that with all the other x squareds. 3 times negative 8x, negative 24x. And then 3 times 17, that's 51, right? Let's hope so. And now I've got all of these like terms lined up. So it's a lot easier to add. Like you can do it all spread out, but then you have to go hunt and find everything. So x to the 4th minus 12x cubed plus, I want to say 52x squared minus 2, carry the 1, 92x plus 51. And I'm going to check my notes and make sure that that's what I got the first time I did it. And it is. Yay, what a great problem.